All right, everybody. So welcome. Tuesday night here. And it's actually really cold here. Last night it got down to almost 0 degrees Celsius. So kind of interesting. If you're there in the chat, please say hello. I see that Rich Mac is there, Pikachu's in there, and Kiss from a Rose. Excellent. More videos about thermodynamics. I'll put it on my list. I do like thermodynamics. So this evening, what we're going to do is we're going to do a little bit of a reaction stoichiometry because I was saying it was getting colder here. This is about the time of year I always think about teaching this topic with my students. So I know a lot of students are struggling with these reaction stoichiometry problems. So we'll work with that some. Then we are going to maybe do a demo, and if we have time, jump over to the Discord server if you're interested. I'm still trying to learn how to use that effectively. We'll see. All right. Good morning, Pikachu, but it's evening here. It's 8:30 at night, so you must be on the other side of the world, which is kind of crazy to be thinking about. Jason's here, Loretta's here, and it's really warm in Texas. Yeah, I bet it is. Awesome. Hey, Isabel, welcome. So let's do this. Let's do some problems. We'll do a demo, and we'll see where we can get in the next 20, 25 minutes. So yeah, Rich, I do have something of a quick start to stoichiometry. I'll share that with you later. Remind me if I don't. That's a good question. Yeah. All right. So let's go over here. This is our first problem that we're going to look at. And so what we're really trying to do is figure out how do we set these up? Because if you set them up, then it's just converting from moles to grams and grams to moles, and that's not too difficult. So most students have problems setting the problem up. If you get that, you're in good shape. So let's do this. If you have some paper with you, kind of try to set this up as we go. And for each one of these, I have a video, separate video in the description where I work the whole thing out. So what happens is you get a problem like this, you're always given something. So sometimes it's grams, sometimes it's molecules. Usually it's grams. So you're given 100 grams, 100.0 grams of, looks like glucose there, C6H12O6. And what you need to do is get it to moles. Once you get it to moles, we have our coefficients from the balanced equation. That's our mole ratio. That'll give us moles of what we're looking for, which is C2H5OH, which is ethanol. And then we just change it back. So really the only big problem you'll have is this. And I'm going to show you how to do that. All right. So to get from grams to moles, I don't want to do all the calculations here. Rich, remind me again, and I'll give you that guide on how to convert from all the grams to moles and moles to grams, all that stuff that you need to know. We're going to divide by the molar mass of glucose. And when we do that, we get 0.555 moles. And we're almost there. We're almost done with this problem. Because if you look at the ratio, for every 1 mole of glucose, we get 2 moles of this. So the mole ratio is 1 to 2. Just multiply this by 2. And once you do that, what do we get? We get 1.11 moles of ethanol multiplied by the molar mass, and that gives you grams. And then you're done. So what do we get? 51.14 grams. And what's so kind of interesting about this is all of these problems follow this pattern. Sometimes they give you grams, sometimes they give you maybe liters or atoms, but it's the same process pretty much every time. Hey, Wesley, good to see you there. So, see how I did that? I'm gonna let you try to set one up now. So, here you go. I even gave you moles of this right here. 7 hours from now, Francis. That sounds like, and it's 2 a.m. there. It sounds like you're going to be up all night. So give this one a try, folks, and I'm going to try to set some of my demo stuff up here. Let's see. So hopefully you have the given here, right? Hey, Joel, welcome. And Heather's here. Excellent. So to get to moles, I've already done it from here, but remember when you go from grams to moles, you just divide by the molar mass. So we had the molar mass, I think this is like 180.16 grams per mole, but you end up with this many moles, which I gave to you. Moles, we're just gonna leave moles there. And what's the mole ratio? So the question is, we start with, the coefficient here is 1. One of these, we end up with 2 of the ethanol. Actually, we're looking for CO2. So we end up with 2 CO2s. So if it's 1 to 2, this doubled, or I should say this doubled because we're looking at CO2. Multiply it by 2. I can't do that in my head. 1.368. And then from moles to grams, you multiply, as we said before earlier, you multiply by the molar mass and you get 60.21 grams. And you'll notice it's the exact same process. It's always the exact same process. And as a side note, we have our largest concurrent number of viewers ever right now. So that's kind of exciting. So again, you're given, change to moles, use the ratio, get moles of what you're looking for and change it back. And yep, Jason, you got it. 60 point, you got 20. That's probably the right answer. Okay, so let me do this because I think, Rich, we were talking about this. Let me put the guide for converting from moles to grams in the chat. Because you've got to be able to make that change. You've got to be able to get from moles to grams and grams to moles and everything. And it's got to be kind of flawless, like really easy to do in your mind. So this guide should make it pretty easy to do. Lots of examples. And that doesn't look like I got the whole URL. There we go. All right, so there's the guide. And like I say, this is usually for members on my channel, but you guys are here, so that's awesome. All right. Yeah, sig figs is always the challenge. Did I get my sig figs here? Yeah, I think I was good. I have 4 up here, so I pretty much stayed there, so I think I'm all right. So Kiss from a Rose, if you're given moles, all you have to do is multiply. You have to multiply by the molar mass. So that's pretty much all you have to do. Yep, Pikachu, I haven't done anything on IUPAC names. I'll see if I can find something for you here before we go. All right, so this guide here, and there's guide, it'll show you how to do molar mass as well, I think. There's a video in there, multiply. Thank you, Jason, for writing that in. All right, let's do one more, and then we'll do a demo, because I feel like if you do too many of these, your head might explode. So a demo is always good to keep that from happening. So there's a bit of a trick. There's something you have to do here first before you can use this pattern here. You see what you have to do before you can use it? Always, always make sure you balance the equation, because that's where we get the mole ratio. It's from the coefficients. So I see I have 1 oxygen here and 2 here. I'm going to put a 2 here. Those are balanced. 2 times 2 is 4. So there we go. Yeah, exactly, Wesley. You got to balance it. So see if you can figure this one out. I gave you the moles of oxygen here, so see if you can do it. So Abdullah, a lot of people fail chemistry the first time they do it. And what happens is often the moles to grams are a problem for them. And oftentimes it's this reaction stoichiometry, because it's not always taught, I think, in a really good way. So hopefully this will help folks out. All right. That's a good question, Joel. Is that right? Yeah, that is correct. And you even got your significant figures correct. Wow. Um, Hi, Eoro. It's great to see you. I saw that you became a member recently. That's so nice. Thank you. Um, I don't have much on Charles and Boyle's law, but I'll see what I have, and I'll post it maybe to the community tab or the members tab, and you can see that there. So I'll try to do that tomorrow. Remind me if I don't. All right. So here we got our moles, 0.1 mole. So we want to know how many grams of water. This is what we're looking for if we start with this many grams of oxygen. So what is our ratio? 1 to 2. I think all of the ratios I have here are 1 to 2. Multiply by 2, 0.2 moles. And then we multiply this, moles to grams, multiply by the molar mass. And the molar mass for water is 18.01, and then we get that 3.6 grams. And it should be 3.6 because we only have 2 digits here, so that's all we can go out. Kiss from Rose says, Hess law got me so much confused. I do not like Hess's law. That's one of the things in chemistry I've never liked. So good luck. I need to do a video on that. Hey, Daniel, I'm glad that it's easy. It should be easy. Teachers kind of make this too hard. All right, well, let's do a demo here. I'm going to come back to me. No, I'm going to go here. And should be 3.6 grams, Francis. So there's a little bit off there. And I'm going to try to move my camera down here. That kind of works. All right. So here is my my desktop chemistry lab. And let's turn some more light on over there. And I'll put some eye protection on. And so what I'm going to do is I'm going to take sodium hydroxide here. And I'm going to put the sodium hydroxide right here in the watch glass. And if it sounds like I'm in a tunnel, it's because I have a face mask on right now, so I don't burn my eyes out. This is pretty strong sodium hydroxide. It's a strong base, and it will light you up. And I don't think I changed my camera over, did I? Yeah, I did. There I am. Okay. So what I'm going to do is I'm going to add copper 2 sulfate. That's the blue stuff here. And it's kind of a light blue. And we're going to do a precipitation reaction. And I'm going to do an X. See if I can do an X. There we go. So what we're doing is we're mixing these two fairly clear liquids together, and we end up with this copper 2 hydroxide. And you should remember that hydroxides in general are insoluble, but that group 1, like sodium hydroxide, that's a strong base. So that stays soluble. But this Cu2SO4, like a star, there we go. All right. Kind of a neat substance. And what's really weird about it, as a precipitate, you can actually pick it up. It's like a blue gunk. I can move it all to one side, make a little mountain of it. So I really like that reaction. I think that's interesting. And if you put something else in, like magnesium hydroxide, you can form, we're actually going to form magnesium hydroxide here. It's not doing it too much. We'll stay with our copper 2 hydroxide. Anyways, we did that a few weeks ago. It didn't work as well as I wanted. And I wanted to make sure I showed you that. So let's go back and give you another problem, yet another problem to try here. So see if you can do this one. There we go. And I'm not giving you this this little guide here. You have to figure it out yourself. See if you can set it up. Jason, you're right. There are some spectator ions in there. Damaged ostrich. I'm happy to have helped you in high school. I used to teach high school chemistry for like 10 years. I like teaching high school chemistry. And Wesley, you're right. That's a precipitation reaction you just saw. It's also a double displacement. Daniel wrote the equation down there. The copper and the sodium, they changed places. All right. So there I am. So try to remember first what you do. We write the desired, the given. And then we want to get it to moles. So we would divide this by the molar mass of CH4 and get moles. But you have to balance the equation. What is this? We have 3. I'm going to put a 2 here. So now we have 2 plus 2 oxygens. That's 4. So we'll put a 2 here. Hey, that's balanced, isn't it? Wow. Daniel, you're on fire, man. I've not tried Kiss Rose. I've not tried copper 2 sulfate and potassium iodide. I'll try that. That sounds interesting. Jason, I'm not sure you got the right coefficients there. Or I didn't get the right coefficients. Make sure you count all the oxygens up. Yeah, there you got it. All right. So we got moles. So now we need our mole ratio. So we're looking at how many moles of this, of CO2, are produced if we start with this. So it's 1, not 1 to 2 again, is it? No, it's 1 to 1. So if you have a 1 to 1 ratio, you're just going to multiply by 1. It's still 0.26 moles. And then to get from moles to molecules, get from moles to anything, you multiply. That's the way I always remembered it as a student. So we're going to multiply this times Avogadro's number so we can get molecules. 6.02 times, some people say 6.022 times 10 to the 23rd, either way. And I would just multiply this by the first number and then add to the 10 to the 23rd. What do I get? 1.6. And that's molecules of CO2. So you can see you can do that a number of ways. I probably would go, Daniel, with just a 1.6 because we only have 2 significant digits here. So there's Caleb. He finally shows up. Good to see you, Caleb. So you can see the process, though, it's the same process, right? You have the given, you get it to moles. Stretch this out here. You use your mole ratio, you get moles of what you're looking for, and convert it back. And yeah, you could even find atoms of oxygen as well. Sometimes they do that on tests. All right, so where are we at? It is 8:49. Okay, let's try one last one here, and then we'll call it good because it's getting a little bit later in the evening here. And I want to try the Discord thing again. We tried it last week. We'll try it again maybe. So how do I find the mole ratio? So Wesley, the mole ratio comes from the balanced equation. Oh, that's interesting to note, Daniel. Hey, thanks, Paul. That's great to hear. That's very motivating for me. So Wesley, so I've got like a 1 to 2 to 2. So if I'm talking about CO2 produced, when I start with this, I would have a 1. That's this. And then the CO2 is 2, 1 to 2 ratio. So it gets, that's really why we balance equations, is to get that ratio. That's the big reason that we do that. All right. So you start with grams, 4.7 grams, and you'd have to get those to moles. I think I ended up with 0.026 when I did it. And so Wesley, here we are at our mole ratio, right? So I'm going to multiply that. It's one of these. I end up with two of these. So I'm just going to multiply it. It's 1 to 2. I doubled it. I'm going to multiply it by 2. And 0.052 moles. And that's of CO2. So one of the things you'll learn is if you have a gas, you can multiply it by 22.4 liters per mole. If it's a fairly ideal gas, moles will cancel out and you'll have liters there. So in that guide, there's a bunch of problems converting moles to liters to practice. And I get 1.2 liters. So that's kind of how you set all this up. It's always going to be the same thing. It's going to almost always going to be this right here. Let me change my opacity up so we can see this. There we go. So it's always going to be the process. You're given something, you change it to moles, you look at the ratio, you find moles of what you want, and you change it to whatever they want. Should be 22.4 liters, Daniel. Oh, I see. The answer should be, I'm getting 1.2 liters, so I think you got something going on. And Jason, you're right. That's at standard temperature and pressure. You're absolutely right. Very nice. So we've been at it about 22 minutes. That's when, with this stuff, you just can't learn anymore. You got to stop. You got to get up, move around, do some breathing, something to kind of refresh those neurotransmitters in your brain. Each one of the problems we did tonight, there's a video for that specific problem in the description. So you can go back over that. And then that guide that I dropped in the chat there somewhere, that has tons of problems and they all have video solutions. So if you need to do this stuff, that's the way to go. I think at this point, somewhere I have, a link to a Discord server. Discord. I think I say it wrong. That's how much I know about it. I'm not even sure how to say it. I'm going to put that in here. And then when I sign off, I'll jump over there. If you're interested, come on over. I'd like to hear about kind of your experiences getting onto the server. How easy or how hard is that? We're not really going to do any chemistry, but just kind of test some technology. So thank you, everybody, for being with us here tonight. We had a lot of folks. That's kind of fun. We broke our record, so maybe next week we'll break that record. All right. Oh, I had to hit send if I'm going to show you the Discord thing. There it is. And Caleb, if you look up in the chat, there is a guide that you can get that should help you out quite a bit. All right. I'm going over to the Discord server. And as always, this is Dr. B. I'll see you next Thursday, or this coming Thursday, I should say. And thanks for watching.